Okay, we want to find theta. We want to find the size of an angle. But that angle now is no longer between 0 and 360 degrees. It's between 0 and 2 pi radians. So this statement right here says to you, look in all four quadrants, but I want you to look and put your calculator in the radian mode to do these. It doesn't say 0 to 360 here. It says theta is less than 2 pi radians and greater than or equal to 0 radians. So your mode's got to be in radians, and I want to find it in all four quadrants. We're going to refer to both of these things. Process is similar to as when we did with degrees. So first of all, the cosine of an angle is negative in two places. So step number one was to state where cosine is negative. It's positive in 1 and 4, so it's negative in 2 and 3. Step number two, find a reference angle. So to find an angle, we go second cosine. Remember, if it's a reference angle, if it's a first quadrant angle, we don't put negative signs on. All the trig functions are positive in the first quadrant, so we never put this negative sign on. But when you do this and you're in radian mode, remember your angle's going to be between 0 and about 1.6. because here is 3.14, about 1.5 or 1.6. So when you go second cosine of 0.734, you're not going to get something between 0 and 90. You're going to get something between 0 and 1.6. In this case, it happens to be 0.747. In the second quadrant, right here, I'll take pi minus the 0.747. And in the third quadrant, I'm going to take pi and add 0.747. Again, it's like 180 minus the reference angle and 180 plus. Those two answers turn out to be 2.395. These are angles, remember. 3.88. Remember, you can't get bigger than 6.28 if you're going within the four quadrants. And again, you could check these. I'm just going to say this once now. So you could check these by taking the cosine of 2.395, that's an angle, and see if it gives you a negative 0.734. And then you could take the cosine of 3.88, that's an angle, and see if it gives you a negative 0.734. The calculator would not be able to give you both of these angles. It would only be able to give you one. So we've got to use our own comprehension of these signs of the trig functions to do that. Again, ultimately leading, we're going to be graphing the trig functions. Where is, maybe you should pause for a minute and do this problem on your own. And when you come back, the sine of an angle is negative in the third and the fourth quadrants. The reference angle is found by taking the second sine or inverse sine. So second button then the sine key, and just put in 0.458. Remember, it's going to be real uncomfortable. This is not going to be a big number. In this case, it's 0.476. Remember, 1 radian is 57 degrees. So this is probably, half of 57. About a 25-degree angle is what we're talking about. But in the third quadrant, we'll take pi and add 0.476. And in the fourth quadrant, we'll take 2 pi and subtract 0.476. And the two answers for this problem should turn out to be, hopefully I'm going to read my notes correctly, 3.617 and 5.807. Oh, cosecant, darn. Well, it's like sine. And sine is positive in the first and the second quadrants. The good news about this one is when you find the first quadrant angle, or the reference angle, I'm sorry, it will be one of your answers. To find your reference angle, remember, this is how I remember this. I'm going to put that over 1. And I know I've got to go to find an angle, I've got to go second button, and then whichever trig function it's the reciprocal of. So that's sine. But since cosecant is this number over this number, it's a fraction, then sine is the flip of that. So this is what you would type in your calculator. And that should give you 0.275. So your two answers in the first quadrant is just the 0.275, and then in the second quadrant, pi minus the 0.275. And let's see, pi minus is 2.867. Again, one more for you to try. Pause if you'd like before you watch me do this. Tangent is positive in first and third. The reference angle is found by taking second tan of the 1.236. It's going to be a number between 0 and 1.6. This turns out to be 0.891. Again, it's getting close to 57 degrees because 1 radian is 57 degrees. This is my answer for the first quadrant angle, and my third quadrant angle, where tangent is positive, is going to be pi plus that 0.891, and I get 4.033. All right, let's go ahead and scroll a little bit to see this next problem. Just a little. This is going to lead us into some stories, some applications of arc length, areas of a sector, and some physics problems involving angular speed and velocity of a point on an object that's rotating in a circle. So we're going to find the length of arc of a circle. So it's a portion of a circle, circumference, a portion. The radius is 10 inches. That intercepts from the center of the circle by an angle of 3 radians. So let's go ahead and draw any old circle. So here we go. And I'm going to draw its radius. And now, along that circumference of the circle, I'm going to lay 3 radiuses off here. So there's 1, there's 2, and there's 3. So I'm looking for how long that red line is. But don't forget that this is 10 inches, the radius. Well then, if there's 3 radians, or almost 180 degrees, then this length of arc would be 10 inches. So would this one, and so would this one. And I would then just be able to say that the length of the red line adds up to be 30 inches in length. You could also write that as a ratio if you'd like. So you know that the circumference of a circle is 2 pi times the radius. So you could take 2 pi times 10 and get 62.8 inches. But we've taken 3 out of the 6.28 radiuses of that 62.8 inches. Here's a way to do this. Or you can do this in degrees. You can convert this to be about 170 degrees out of 360 degrees. Now again, it's whatever 3 times 180 divided by pi is, so I didn't do that in advance, so it's about maybe 170 or so, 170 degrees. So 170 out of 360, and you could multiply that by the full circumference, the 62.8. What we're going to do is we're going to say the length of that arc is found by taking the angle theta in radians, 3 of them, and multiply by the radius. And this is going to be a formula we're going to use in Chapter 8, Section 4. This is going to be arc length. We're going to use the angle in radians, and we're going to multiply by the length of the radius. Good enough.